Hey, my name is Nada, and today I'm going to present you the final project of my probability course in Scholar Data Pacman, which is about the insurance premium and the variables affecting it. So as for the outline, today I'm going to talk about the first, of course, introduction, and then I will talk about a little bit about the data set and also the result of my descriptive statistical analysis, categorical and continuous variable analysis, the variable correlation, hypothesis testing, and the conclusion about it. But first, I will introduce you about the project that I did. It's about assessing what does play into the determination of the premium of health insurance, which is affected by multiple factors. And the assessment of that, it affects the risk profile of the insured users, which involves the variables correlated with the premium, such as sex, age, region, smoker status, the number of children and insured altogether. Things that I did for the analysis was doing the descriptive, categorical, and continuous variable analysis, and then also the variable correlation, and also lastly the hypothesis testing. This whole analysis was carried in Python using NumPy, Pandas, SciPy, Matplotlib, and Seaborn packages. So the data set. This is the insurance data in the United States, and the data provided are the age, sex, BMI, number of children, the smoker status, the region of living, and also the charges that they pay. And you may notice down here that there is a slight difference about it, and I did encode the data set for later use. For example, for the correlation analysis, because it's easier that way. So onto the first part, the descriptive statistical analysis. I calculated the mean of age using NumPy here, which is basically just summing all of the age of the insured users divided by the length of data. And then from that, I got 39.21 as the mean of the age of the insured users. Mean BMI of smokers, I also did with NumPy, and in the end, I got 30.71 as the mean. The charges variance by smoker status. Smoker status is whether they smoke or not. Here, I was using the native function in Pandas, which results in the smoker has a higher variance rather than the non-smokers by 10 times, almost 10 times. The mean of age of the smokers by sex was also done using Pandas, using the crop by function. And then we can see here that the mean age of the smokers by sex is not so different from each other. It's only by 38.60 for the female and 38.45 for male. For the mean of charge by smoker status was also done in Pandas and results in the mean of charge for smoker is 32,050, and for the non-smokers is only 8,000, which is a huge difference because the smoker has almost 4 times as big as the non-smoker. For the mean of charge, the smoker, the mean of charge by smoker status for people with BMI is above 25. Those who smoke have a pretty high mean of charge, 35,000, and for the non-smokers, they are averagely charged 8,600 And the BMI by sex, this does not differ very much. It was done in Python using the pandas function again. And for female, the mean BMI is 30.37, and for male, it's 30.94. BMI by smoker status is, for smoker, it's 30.71, and for non-smoker, it's 30.65. So the analysis from the descriptive analysis from that is that the smoker and non-smoker users are definitely in a similar age range, and there is also a huge gap between the premium of smokers and non-smokers, and it's almost 4 times as big. And the BMI by sex and smoker status are similar, basically. On to the next step, I did categorical variable analysis, and I was looking into the higher charges by sex, which can easily be visualized using the help of Seaborn and also Matplotlib, of course. And by looking at the visualization, it does not make any sense if you use the mean to justify, to calculate like which sex has the higher charges, because the distribution of the data is multimodal. It makes more sense if we take a look at the median, which is for male 9,400-ish, and for female it's 9,300-ish. So it's quite similar. For the premium distribution by region, it's also important to see the distribution first. How does it look like? And then we know that it's not like symmetrically shaped, like the bell shape. So it makes so much sense if we use the median as well here. And if you take a look into the here, we can see that also the median is like only differ by only a bit from each other. Like from southwest, it's 8,799. Southeast is 9,294. Northwest is 10,057, and northeast it's 8,965. Looking into the data proportion of each region, we can see that almost all of them are like distributed evenly, and we can see here in the southeast it has like a bit more data, but it's not like by a lot much. The data proportion of smoker and non-smoker, here we have only like 20% of the whole injured users are smoker, and almost 80% of them are non-smokers. Yeah. And the probability of someone is a female given that they are smokers is only 42%, and the probability of someone is a male given that they are smoker is 58.03. And here it's just basically the premium distribution in each region, which I showed you earlier. And analysis for this section is that first, male has higher charges than female, and then there is a lot more non-smoker than smoker. The data is almost equal in all regions, but it does not make any big difference. And then Northwest has the highest charges mean, while Southwest is the lowest, and there is a higher change, a chance that is the smoker is a male than female. I'm sorry, there is a typo here. And also for the continuous variable analysis, here to do this, I added another column to define the class of the BMI of each insured user. The definition of the like which BMI falls into the category of overweight or healthy is actually regulated by the BMI itself. And then yeah, I just categorize them into like 4 categories, and then we can see here that the probability of charges based on BMI for underweight people is much lower than those who are obese. The probability of smoker with BMI is higher than 25 getting charged of $16,700 is a 98.17. The probability of someone getting charged $16,700, given that they are smokers, is 92.70. And there is a higher probability for someone whose BMI is higher than 25 to be charged or more than 16,700. And also, the probability is way higher, like even more higher for someone who smokes with BMI above 25 to be charged 16,700 rather than those who do not smoke with BMI above 25 to be charged above 16,700. So yeah, from the section, we can see that people who are obese have a higher chance to be charged highly than those who are underweight. The probability of smokers being charged highly is very high, and it gets higher if their BMI is above 25. The probability of charge highly for someone whose BMI is above 25 is higher than those who don't, and people who smoke with BMI is higher than 25 has a higher chance to be charged highly. And then we go on to the correlation variable analysis. So what I did first is that I did a heat map to visualize the correlation of each of the variables. And we can see here that the correlation with charges is only like high for the smoker variable. We can see that age is only like lowly correlated, BMI as well, sex is basically negligible, children as well, and region as well. But the only thing that is standing out is smoker status. And if we elaborate that, whether it's smoker versus non-smoker has a higher charges, we can see that for smoker, the charge is strongly correlated with the BMI. And meanwhile, for non-smoker, the charge is only moderately positively correlated with age. Because like in the previous sections, we also talk about BMI above 25. I also did some correlation here. For people whose BMI is higher than 25, the smoking status strongly correlated with charges. And for people whose BMI is lower than 25, smoking status is only moderately correlated with charges. For both sexes, the charges, both of them are strongly correlated with the smoker status, but in male insured users, it is way higher than the female. And what about those who got high charges? And this is also interesting because we also saw about it earlier, right? But if you talk generally, what kind of thing that plays into role that makes the charges higher for them is that BMI, like we can see here that the BMI is strongly correlated, like or moderately correlated with the charges. For people who smoke, both BMI and charges are strongly correlated with each other. And for non-smoker, it's age and charges. For people whose BMI is above and below 25, for people whose BMI is above 25, there is a moderate positive correlation between BMI and charges, and low positive correlation between smoker status and charges. And for BMI under 25, it's basically negligible. And for sex and higher charges, for male, BMI is moderately correlated with charges, and smoker status only slightly correlated with charges. Meanwhile, with female, the BMI is also moderately correlated with the charges, yet it has a higher correlation value than male. So for the BMI, the smoker status and charge seem to be correlated with each other somehow. But if we say generally, it's only smoker status, which correlate strongly with the charges, and the charges is strongly correlated with the smoking status, especially for those whose BMI is above 25 for both sexes. And for people who are charged highly, what is like really strongly correlated are smokers and the BMI and charges. And then after that, I also did some hypothesis testing. First, is it true, like whether the smokers' charges is higher than the smokers? The null hypothesis is the smokers' charges are lower than the non-smokers, and the alternative hypothesis, or the hypothesis, is that smokers' charges are higher than the non-smokers. And after some calculation in Python, we got the result that it has a p-value of 0, which just means that the null hypothesis is rejected. Because the mean of the insured users who smoke is higher than those who don't. So it means that there is a significant difference between the insurance charge of smokers and non-smokers. Second, do people with BMIs above 25 really have higher insurance charges than those below it? We go from the hypothesis that people whose BMI is above 25 have higher insurance charges than those whose BMI is below 25, while for our null hypothesis, we have people whose BMI is higher than 25 does not have higher insurance charges than those whose BMI is above 25, under 25, I'm sorry. And using the t-test, the return p-value is 0.0001, which means that the null hypothesis is rejected, and the result is basically statistically significant. The third hypothesis that I test was whether the insurance charges of male is higher than female. I did the t-test, and then it returned the p-value of 0.0253, which means that null hypothesis is rejected because the significance is 0.05, which means that the mean insurance charges of insured male users is greater than female users, and the difference is statistically significant. And then for conclusion, there seems to be like three moderate until strongly correlated variables, which are smoker status, BMI, and charges, and three proven statistically significant hypotheses are smokers' charges is higher than non-smokers, people with BMIs above 25 have higher insurance charges than those below it, and insurance charge of male users is higher than female. That's it. Thank you.